up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. Transmission media and transceivers, they are essential components of network infrastructure where they ensure reliable communication across different environments. And in this video, we're going to talk about the key concepts that are outlined in Objective 1.5, where we are comparing and contrasting the various types of transmission media and transceivers. All right, so let's start off with our 802.11 standards. So the 802.11 standards, they govern wireless local area network communication, and they define the specifications for different Wi-Fi technologies. So we have 802.11a, and this operates in the 5 gigahertz band with the maximum theoretical throughput of 54 megabits per second, and it is less prone to interference but has a shorter range compared to 2.4 gigahertz standards. Then we have 802.11b. This operates in the 2.4 gigahertz band and supports up to 11 megabits per second. It has a better range, but is more susceptible to interference from other devices. You got 802.11g. This combines the benefits of 802.11a and b, operating in the 2.4 gigahertz band, and it has a maximum speed of 54 megabits per second. You have 802.11n. This supports both 2.4 and 5 gigahertz bands, and it introduces MIMO, which stands for multiple input, multiple output technology, where it achieves speeds up to 600 megabits per second. Then we have 802.11ac. This focuses on the 5 gigahertz band, providing gigabit speeds by utilizing wider channels and advanced MIMO technology. And then we have 802.11ax, which is also known as Wi-Fi 6. And this enhances performance in dense environments with OFDMA, which stands for orthogonal frequency division multiple access, and multi-user MIMO, where it achieves speeds over 8 gigabits per second. And on your screen right here is a handy dandy little chart that you can use to help you memorize all of these 802.11 standards. So take advantage of that. All right, so let's move on to our next wireless transmission media, and we're going to talk about cellular communication. So cellular communication, this enables mobile connectivity through various generations of technology. We have 3G, and this offers speeds up to 2 megabits per second, and it is suitable for basic internet usage and voice calls. You have 4G LTE, and this provides speeds up to 100 megabits per second with improved latency, supporting high-quality video streaming and mobile applications. And then we have 5G, and this is the latest generation where it offers speeds up to 10 gigabits per second with ultra-low latency and high device density. And it also enables IoT and smart city applications. And then we have satellite communication. So satellite communication provides internet connectivity in remote areas where wired or cellular networks are unavailable. Now, although it offers wide coverage, it suffers from high latency due to the long distance signals that must travel to and from satellites. All right, next let's talk about our wired transmission media. And we're going to start off with the 802.3 standards. So the 802.3 standards, they define Ethernet technologies, which are widely used in wired networks. So the first one we have is called 802.3AF, and this is the power over Ethernet standard that delivers up to 15.4 watts of power over Ethernet cables. We have the 802.3AT. This is also known as PoE+, and it supports up to 25.5 watts of power. And then we have the 802.3BT, and this extends PoE capabilities, providing up to 100 watts of power for devices like cameras and wireless access points. Next, we have single mode versus multi-mode fiber. So fiber optic cables, they transmit data using light, where they offer high speeds over long distances. And there are two main types. The first one is single mode fiber, and this uses a small core in a single light path, which enables transmission over long distances of up to 40 kilometers or more. And this is ideal for wide area networks and telecommunications. And then we have multi-mode fiber, and this has a larger core and multiple light paths, which are suitable for shorter distances up to 2 kilometers. And this is commonly used in local area networks and data centers. Next, we have what is called the direct attach copper cable, and this uses copper conductors for short distance connections, and this is typically within racks and data centers, and these cables offer low latency and high availability. And then we have what is called a twin axial cable, and this is a type of direct attach copper cable to where they are often used for high-speed Ethernet and storage connections such as 10G base-CR and 40G base-CR4 standards. Another wired transmission media is that of your standard coaxial cable, and this features a central conductor that is surrounded by insulation, shielding, and an outer jacket. They are commonly used for cable TV, broadband internet connections, and legacy Ethernet networks. You have your various cable speeds. So wired transmission media, they offer varying speeds depending on the type of cable and technology. So you have Cat5e, and this supports speeds up to 1 gigabit per second. Cat6, this offers speeds up to 10 gigabits per second over short distances. Cat6a, this extends 10 gigabit per second support up to 100 meters. Then you have fiber optics, where this provides speeds up to 100 gigabits per second and beyond. Next, we have plenum versus non-plenum cable. So plenum cable, this is designed for use in air handling spaces. And plenum cables, they have fire-resistant jackets to reduce smoke and toxic fumes in case of a fire. And then you have non-plenum cable, where they lack the fire-resistant properties of plenum cables, and they are used in areas where fire safety regulations are less strict. All right, so let's move on and talk about transceivers. And first, we're going to talk about protocol support. So transceivers, they convert electrical signals to optical signals and vice versa, supporting various protocols such as Ethernet, which is widely used for local area networks. And the transceivers, they support speeds from 1 gigabit per second to 400 gigabits per second. And then you have what is called the fiber channel. And this is designed for high-speed storage area networks where they support speeds up to 128 gigabits per second. And yes, the spelling of fiber, F-I-B-R-E, that is spelled the correct way. All right, so let's quickly talk about some transceiver form factors. So transceivers, they come in different form factors, providing flexibility for network devices. You have what is called a SFP, or a small form factor pluggable. This is compact and hot swappable, and the SFP transceivers, they support speeds up to 10 gigabits per second. And then you have what is called the QSFP, or the quad SFP, and this is a larger variant of SFP. And the QSFP transceiver, this supports higher speeds, including 40 gigabit per second and 100 gigabits per second. All right, so let's move on to talk about some common connector types, and we have fiber optic connectors. So the first one is called the SC connector, or the subscriber connector, and this features a square-shaped design, and this is commonly used in data centers. Then you have what is called the LC, or the local connector, and this is a smaller connector with a latch mechanism that is ideal for high-density installations. Then you have the ST, or the straight tip, and this is a bayonet-style connector that is often used in legacy networks. And then we have what is called the MPO, or the multi-fiber push-on, and this supports multiple fiber strands in a single connector, and they are commonly used in high-speed data centers. The next connector types are your copper connectors, and the first one is your RJ11, or your registered jack 11, and this is a 4 to 6 pin connector that is used for telephone and DSL connections. Then we have your RJ45. This is an 8-pin connector that is used for Ethernet and network connections. You have your F-type connector, and this is a screw-on connector that is used for coaxial cables and cable TV and internet applications. And then you have your BNC, and this is a quick connect disconnect coaxial cable connector that is used in video and radio frequency applications. All right, so to wrap this lesson up, understanding the differences among transmission media, transceivers, and connectors, this is crucial for designing and maintaining efficient networks. So whether you're dealing with wired or wireless technologies, the choice of components, this does impact performance, reliability, and scalability. And this knowledge not only aligns with the CompTIA Network Plus objectives, but also prepares IT professionals to make informed decisions in real-world scenarios. All right, so with that being said, let's do some check on learning. So the first question is, which of the following transmission media is best suited for long distance, high-speed data communication with minimal signal loss? Would this be a coaxial cable, a multi-mode fiber, a single mode fiber, or a direct attach copper cable? And the correct answer is it is single mode fiber. So, single mode fiber, this is designed for long distance communication and offers minimal signal loss compared to multi mode fiber or copper based cables. Its narrow core allows the transmission of a single light mode, reducing dispersion and enabling higher speeds over long distances. Next question. What type of connector is commonly used with coaxial cable for television and internet service? Would this be an SC connector, the F type, the RJ45, or the ST connector? And the correct answer is the F type connector. So, the F type connector, this is a threaded connector that is commonly used with coaxial cables in television and internet services, and it ensures a secure connection with minimal signal loss. And our final question, which of the following transceiver form factors supports higher data rates and is commonly used in data center applications? Would this be a small form factor pluggable? Would this be a registered Jack 45? Would this be a BNC connector? Or would this be a quad small form factor pluggable? And the correct answer is this will be a QSFP. So QSFP transceivers, they support higher data rates. They are typically used for high-speed networking in data centers. And QSFPs, they can handle multiple channels of data, making them ideal for applications requiring higher bandwidth, such as 40 gigabits per second or 100 gigabit per second networks.